I'd like to give a demonstration of the tools available to the operator of the Paris system when they're making an implant, a cranial implant. As you can see, we already have a skull generated from CAT scan data being displayed on the screen, and in the middle of the skull you see a large defect. And the first tool I have at my disposal is the wand that I hold in my left hand, and I can grab the object and turn it in any orientation I choose. You can see that the skull is cut on the sagittal plane, cut in half, so I can work both from the inside and the out. The second tool that I have in my right hand is the stylus of the haptic system. And as you can see, the little green ball represents the head of the various tools that we have at our disposal to work on the design of the implant. Okay, the first tool I have is the one that's referred to as the add clay tool, and it's essentially the same as squirting toothpaste from a toothbrush. I can add volume to the edges of the defect simply by pressing a button on the side of the stylus and moving along the cut edge, trying to maintain the three-dimensional contour of the clay at the same time. And as you can see, I can add multiple layers and essentially fill in the void very quickly with a workable volume. Now I can turn the model after I've covered the outside just to make sure I have sufficient volume on the inside, and it looks fine for purposes of our demonstration. The next tool that I would use to refine the volume that I've just added would be the carving tool. Alright, so now we have the carving tool, which allows me to reshape the excess volume that I've added with the add clay tool. And what I can do is turn the model in an orientation that allows me to see the contour, and just position it a little bit. And now I can feel the edge of that clay, and I know that's more than I need, so by pressing the button once again, it acts very similar to a Dremel tool with the burr in it, and I have the sensation of grinding away the excess material. And with the help of the glasses and parallax, I can look around the model as I work, and it simulates very closely the actual act of sculpting and then tooling away excess material. I'll just proceed down here a little bit more. Moment at first adding the clay, then using the carving tool to modify that, remove the excess that I've added. This tool is called a smoothing tool, and by pressing the button once again, I can run it over the surface of the implant, such as it is, and begin to refine the surface, working toward a nice smooth surface for the final implantable device, or the stereolithography file that it will finally become. And as I move over this, I can feel the high spots and the low spots and know where to apply pressure, know where to skip. I can grab it with the stylet, with the wand, and I see a bump here that I can work on to smooth down. And by either making the diameter of this sphere, the green sphere, larger or smaller, I can change the way that the added volume is manipulated. A larger sphere will create a smoother surface over a larger area. A smaller sphere will work in a smaller area for detail work. So we would work at this until we have a nicely smooth surface, and then move on to the next tool. Well, we've spent some time going back and forth between the various tools, and now have what I find to be an acceptably smooth, well-formed implant. And the next step is to remove it from the defect. And in the process of sculpting, the implant actually gets caught in undercuts on the inner surface of the skull. There's a tool called the push tool that allows me to literally push from the back on the implant, and will remove those undercuts so that the implant will slip in and out of the hole in the skull very precisely, and give us just the precise fit that we want. Okay? So what I do is I try to hold the tool as perpendicular to the surface of the implant as I can, because I want to push it out in a straight line, and just apply a little pressure and push, and you probably saw the implant move. It takes a few moments for the calculations to occur. And when we get some movement on the tool, we'll know that we can take a look at the results. Here we go. And I can grab it, and you can see, I'll try to bring it up and enlarge it, that the implant has now been pushed free of the rest of the skull, and that would fit back into that defect in a very precise manner. Now, just to prove that we've actually created a separate piece from the skull, I can grab the implant and remove it from the defect, and you can see, I believe, well, that we have an implant now free of the defect.